In this video, I want to talk about taking your ability to do stoichiometry calculations and using them to determine which of the reactants in a chemical reaction are actually limiting the reaction or stopping it from proceeding. Remember, as we've been doing stoichiometry calculations, we've been focusing on mole ratios. And mole ratios are showing us the relationship, the proportional relationship between any two substances in a chemical reaction. In order to determine mole ratios, you have to start with a balanced chemical equation because that is showing you the perfect recipe for putting together the reactants to get to the perfect amount of products. In this video, I'm going to be focusing especially on the reactants because we'll be looking at is one of the reactants limiting the reaction or stopping it from proceeding. You know that look at this particular equation, we have ammonia and nitrogen monoxide going together to produce nitrogen gas and water. And if we think about the mole ratio, it tells us that we have 4 moles of ammonia reacting with 6 moles of nitrogen monoxide. And that's the perfect balance, 4 moles of one reactant compared to 6 moles of another, in order to make the greatest amount of products. However, if the actual amounts of your two reactants do not equal this perfect mole ratio, one reactant then will limit or restrict the amount of product. It will basically stop the reaction and not allow it to continue. So the limiting reactant then determines the amount of product that can be made from that chemical reaction when you're working in real life with real amounts of your reactants. You also sometimes see this referred to as a limiting reagent, which is a little bit more old-fashioned term. In comparison to the limiting reactant, we have the excess reactant. This is the one that there's extra, there's plenty available, and because there's plenty available, it will not be fully consumed, it will not be fully used up by the reaction, and there's going to be some left over. So let's think about limiting reactants in a specific example. We have our formula here for making ammonia, where nitrogen gas, 1 mole of nitrogen gas, combines with 3 moles of hydrogen gas to produce 2 moles of nitrogen. Well, what if you start off with 3 moles of nitrogen gas and they are reacted with 6 moles of hydrogen gas? You run the reaction. We think about this. The formula here is kind of our perfect recipe. Let's go through it one time. So we're going to use 1 mole of nitrogen gas, and we'll use it with 3 moles of hydrogen gas to make our 2 moles of ammonia. But we're not done yet. We haven't used things up, so we can run this again. We can do another mole of nitrogen gas plus 3 more moles of hydrogen gas to make 2 more moles of ammonia. At this point, we have used up 2 moles of nitrogen gas, 6 moles of hydrogen gas, and we produce 4 moles of ammonia. Our amounts that went into this process were 3 moles of nitrogen and 6 moles of hydrogen. So we've used up this hydrogen. We have spent all of our hydrogen. This has now become our limiting reactant. So I keep on saying that wrong today. Limiting reactant. We have run out of hydrogen gas. We still have 1 mole of nitrogen gas left over. This is our excess reactant. We have some left over. So the hydrogen gas basically is what has stopped the reaction from occurring. We can't make any more ammonia because we don't have any more hydrogen gas. We do have an extra mole of nitrogen gas available, but we can't do anything with it because we have run out of the other reactant. So let's do some calculations then with this. Let's assume the reaction, the silver reacts with sulfur to form silver sulfide, according to this reaction, where we have 2 moles of silver plus 1 mole of sulfur, making 1 mole of silver sulfide. So our question is, what is our limiting reactant when we are reacting 0.464 moles of silver with 0.12 moles of sulfur? So again, this is moles. Both of the units in this problem are moles, so moles are being compared to moles. We can do our mole ratio, and we're being concerned about silver and sulfur. So we're going to create this equivalent fraction. We go back to our balanced equation to see we have 2 moles of silver to react with 1 mole of sulfur. We are given, we'll just start with silver, we've got 0.464 moles of silver, and we want to know how much sulfur then will react with it. So if you go ahead and do the math, you'll find that X will equal 0.232 moles of sulfur. So that's how much sulfur you need if you're going to use up all of the silver that you've been given. But we don't have that much. We have only 0.12 moles, and we need 0.232 moles. And so sulfur is going to be our limiting reactant. We are going to run out of sulfur before we run out of silver. So along with doing the math calculations on limiting reactant problems, you have to be able to think logically about what your answer tells you. Here we get a bigger answer telling us how much sulfur we're going to need than what we have available, and so it shows us that sulfur is what we're going to run out of. Now let's do a little more complicated problem that has several steps in order to figure things out. The question says, when zinc reacts with hydrochloric acid, zinc chloride and hydrogen gas are produced according to the following reaction. So we see we have 1 mole of zinc plus 2 moles of hydrochloric acid producing 1 mole of zinc chloride and 1 mole of hydrogen gas. So the question asks, what is the limiting reactant when we have 8 grams of zinc reacting with 8 grams of hydrochloric acid? Remember that you cannot compare 2 substances on a gram per gram basis because everything's going to have a different atomic mass and different molar mass, but we can compare them as moles. So we've got to turn these grams into moles before we can do anything else. So let's start with our zinc. So we've got a mole-gram conversion going on here. We've got 8 grams for zinc, and so it's going to have 1 mole in this spot, and then we need to look up our molar mass for zinc. On the periodic table, you'll see that it's 65.38 grams. And if you do the math, if you divide 8.00 by 65.38, you're going to get an answer of 0.122 moles. So this is how many moles of zinc are found in that 8 grams. Let's do the same thing with our hydrochloric acid. It also is 8 grams. And so the mass is the same, but the moles will not be because it's a different substance. So if we look at the molar mass for hydrochloric acid, you have 1 hydrogen and 1 chlorine molecule. Add those together and you get 36.46 grams. And again, doing the math, dividing 8 by 36.46, you're going to find that you in this case have 0.219 moles of hydrochloric acid. So same mass in grams, but 2 very different numbers in moles. Now that we have moles, we can go on to compare these 2 substances. So again, just kind of keeping it in the same order, zinc as compared to hydrochloric acid, though it doesn't matter, you can do it the other way around. We want to create our 2 equivalent fractions, the first one coming from our balanced chemical equation. So back up here looking at our coefficients, we have 1 mole of zinc as compared to 2 moles, or reacts with 2 moles of hydrochloric acid. And so on the right-hand side, we're going to just pick one of these moles that we've calculated. So I'll just stick with the zinc, and so we'll have 0.122 moles of zinc, and then we'll just put an X here. So in a perfect world, if we had the perfect relationship between zinc and hydrochloric acid, we would be using how many moles of hydrochloric acid? If you go ahead and solve for X, then X is going to equal 0.244 moles. So that's how many you need to react completely with this 0.122 moles of zinc. But you can see right away that we don't have enough. So again, you have to apply some logic. We only have 0.219 moles instead of 0.244 moles. We don't have enough. And so that tells me that the hydrochloric acid is going to be our limiting reactant here. We are going to not have enough because you need 0.244, we only have 0.219. So after you do the calculations, you need to go back and compare it to what you have in order to logically decide which one of these 2 reactants is going to limit the reaction. Now, often you are asked to go on even further after you've done the calculation, determined what is the limiting reactant, then you're asked to figure out how much is left over. So how much zinc is left over. We figured out that the hydrochloric acid is our limiting reactant, so the zinc is going to be our excess reactant. We've got more than we need, so how much is going to be left over when we do this problem? Same amount, 8 grams of zinc, 8 grams of hydrochloric acid. We already calculated that that is 0.122 moles of zinc and 0.219 moles of hydrochloric acid. So how much would we need then of the zinc since our hydrochloric acid is our limiting reactant, this one's going to be used all the way up. How much zinc is that then going to use up? So again, we're going to do a mole ratio comparison of these two substances. And so we have our balanced chemical equation for the first side of our equivalent fractions. And in this case, we're going to put the X in the zinc because we want to know how much zinc are we actually going to use with the amount of hydrochloric acid that we actually have. In the previous problem, we were thinking about ideally how much hydrochloric acid would we need. But here we're saying, okay, we have this much. How much zinc are we going to use? And again, if you go ahead and solve the math, do the cross multiplication, you'll find that the amount of zinc that we're going to need is 0.109 moles. So we have 0.122. We have more. Remember, this is the reactant that we have in excess. This is how much we're going to use up reacting with the amount of hydrochloric acid we have. How much is going to be left over? Well, at this point, we're just going to be doing some subtraction. We take the amount that we have, 0.122 moles. We subtract the amount we're going to use, 0.109 moles. And if you do the math, you find that that's going to be 0.013 moles left over. This is how much zinc will be left over. But we can't really measure moles. We count them with moles, but we measure them in grams. So it's time for another mole-gram conversion. This time we've got our 0.013 moles. So that means moles are going to go in this spot, and we have to figure out the grams. What is this substance we're talking about? Well, it was our X. It was zinc. So we need to have the molar mass for zinc, which is 65.38. And then we're going to be multiplying this time, which will give us an answer of 0.850 grams left over. So to answer our question, how much zinc do we have left over? Not quite 1 gram, 0.8 of a gram. So even though we're looking at 8 grams of each, the same mass measurement, and twice as much moles of hydrochloric acid needed than zinc, we only have a tiny amount of zinc left over. We don't even have 1 gram left over because we can't compare grams of one substance to grams of another substance. We have to compare it with moles, and stoichiometry is all about working with moles and being able to bounce back and forth between the grams of a substance and the moles of a substance. So that's how you work with limiting reactants, figuring out which substance you don't have enough of, which one you're going to run out of first, doing stoichiometry, and then doing some logical thinking in figuring out what the correct answer is.